Hello students, welcome to another math lesson. This time round, in this video, we are going to look at what we call number sequences. Specifically, we are going to focus on arithmetic progression, but you don't need to worry too much about the vocabulary at this point. Just understand that we are going to look at number patterns, right? That's the informal way to call this. Now, when we talk about number patterns, there are this thing called sequences. So let me just begin by explaining, right? Sequences simply means numbers that runs in a certain pattern in this manner. For example, 1, 3, 5, etc. right? Whereas another type of number patterns, we call it the series, right? Series will be where we sort of add them up together. 1 plus 3 plus 5 plus and so on. This is the one that we're going to focus on for now. So let's begin, right? There are some things that we hope to understand through this exercise, that is, realize that pattern models the regularity in the world we live in. So in our world, real world context, when we observe, many things actually follow certain pattern, right? So if we can actually understand the pattern and put it into a mathematical model, we can do a lot of prediction and enhance our understanding. So sequences are actually functions, okay, where each term in the sequence is uniquely determined by its term position, right? There's a term position based on the specific rules, okay? So this is what we're going to do. We're trying to make use of number patterns and number sequences to make sense of regularity in the world. So let's begin by looking at an example. So here is a sports stadium, right? And if you understand how sports stadium works, there are seats around where the action is in the center, but in between, from one row of the seats to the next row, there are actually different numbers of chairs, right? Number of seats, because on the outer ring, you can actually put more chairs. So in a simplistic example that we have here, is that we have rows of seats, and from one row to the next row, we are going to increase by 4 seats. So in the first row, there are 20 seats. In the second row, there are 24 seats. So if we recognize the pattern and the rule, which is increased by 4, then we can predict what will happen in the third row. What do you think will happen in the third row? You can pause the video and fill in the blanks first. All right, did you get it right? Yes, all we need to do is keep adding 4. So we have 28 in the third row and 32 in the fourth row. And it goes on. And we can actually make prediction, if you understand, what will happen in the 10th row. So in the 10th row, we will have, well, let me do a quick calculation using my calculator. We will actually have 56 seats. Did you get that right? How about the 34th row? Well, 34th row is a lot larger, but it is still possible to work it out, right? If you just keep going, you should get 142 seats, right? So how do I actually get this? Well, it's actually 20. Let me change the color here. The first 20, right? And then after that, we are going to add 4, 9 times, right? In this case, we're going to add 4, 33 times. Okay? So that's actually how we actually managed to get the number of seats. So with this understanding, how many seats are there in the R row? Well, what will happen here is it will be 20 plus 4 times. Now it will be 1 less than R, right? It will be 1 less than R because the first row is already 20. So if we were to simplify this, we will end up with 20 plus 4R minus 4, which is equals to 16 plus 4R. Well, later on, we'll see there's a very structural way to actually obtain this algebraic form, general form, right? So in the final question here, in the introduction, say what happens if there's 416 seats? Which row will it be? So once we have actually obtained this, okay, we can work backwards and says, okay, that means if I have 16 plus 4R, right, this is actually my seats. So if there are 416 seats, then 16 plus 4R is actually equals to 416. That means 4R equals to 400. r equals to 100, right? So it will be in the 100th row. That's the solution. Okay, so that's the introduction. So what happened, right? Now, the next thing we want to look at is what we just look at is something called the linear sequences. Linear simply means that if we were to plot this on a straight line, on a graph, it will be a straight line. And some characteristics is that there's going to be a common difference, as highlighted here. There's going to be a common difference. And sequences with common difference, okay, we're just going to call it linear sequences. So in the earlier example, we have seen that the common difference is actually 4, because from one row to the next row, there's a difference of 4. So here are some examples of linear and non-linear. As you can see, in each one of these, there's a common difference on the left, right? Over here is plus 8, and so on, right? So over here, I plus 3 here, plus 4 here, you realize the difference is not common. So these are non-linear sequences on the right, linear sequences on the left. We will focus on the one on the left, but just in case if the sequence on the right do appear, it's good to actually know how they work, right? You can see some of them is quite obvious, some less so, right? So over here, of course, you can see incremental difference, right? In this case, this will just be multiplying by -1 from one term to next. This one, okay, this is odd, right? You have plus 2, plus 2, plus 2, and then there's a plus 3 here. So there isn't a clear pattern over here, okay? Then of course over here is a subtraction, and then you have a subtraction, but you can see that this one do have some kind of pattern. We subtract like half the value lesser. And of course the final row, I'm sure you're familiar with this. This is 1 squared, 2 squared, 3 squared, 4 squared. These are perfect squares, okay? So there are many different kind of sequences, okay? But first we categorize them as linear sequences and non-linear sequences. So here are some examples. Can you identify which one are linear sequences? Pause the video and actually try them out. And we're back. So if you look at this, okay, you can see that from here, one term to the next term, we actually subtract by 7. So the common difference here is -7. Over here, we have a situation where we have 7 minus 2.5 is 4.5, right? 4.5, and then if we subtract 2.5, subtract 4.5, we get -2. It seems to make sense. Yes, so in this case, the difference is -4.5. Okay, over here, we can see that the difference is just 3, right? Okay, adding 3. So yeah, these are the common differences. As you can see, they can be in the form of integers. You can have negative numbers in there, even decimals, and algebraic expression. They do work, okay? So some vocabulary, right? Sequences, we have already explained them. Now, each number in the sequence is actually called a term. And the first term, we're just going to call it first term, right? And we denote it using, we can denote it using this form, where we have t followed by a subscript, right? This is called a subscript. Okay? So we can use a subscript to denote the term number. So we can have term 1, 2, 3, 4, 5, etc. And then when we have an n term, we call this the general term. Okay? And of course, linear means there's a common difference. So these are some words we need to know the meaning of. Okay? And here is what we have sort of already done, right? So this is called the general term of a linear sequence, right? So what happened is that to find any term, the n term, okay, we just take the first term plus the term position -1 multiplied by the common difference. Okay, so let's take an example, right? For example, earlier we have this example where we have the stadium, and the first term is 20, and we actually keep adding 4, right? We keep adding 4. So maybe just write it in this way. The first term is 20 plus 0, so it's just 20, right? But in the second term is 20 plus 4. The third term is 20 plus 4 plus 4. The fourth term is 20 plus 4 plus 4 plus 4, etc. Right? Now what we need to notice is that in the the first one may not be obvious, right? But in the second one, we'll realize that it's actually multiplied, the number of 4s, actually there's only one of them. And the term here, right, is actually the second term minus 1, multiplied by 4. Over here, we have 20 plus 3 minus 1 times 4. And then down here is 20 plus 4 minus 1 times 4. So if we check if it works for the first one, this is 1 minus 1 times 4. It matches, right? So in this case, of course, Tn, right, that's the n number. This will be 20 plus n minus 1 times 4. Well, since in this case, right, in this case, my a is actually 20. I'm going to use the first term, a as the first term, and my common difference is 4. I can simplify the entire formula into a plus n minus 1 times d. And that is the general term, right? So here are some practices. I'll leave them to you to try, right? So I guess it's a good place to pause the first segment of this lesson. You try these questions and then we will compare them in another video. Have a nice day.